back to another Daishinfinity video. In this video, we're going to talk about the derivative of the arc cosine of x, which is the inverse function of cosine of x, which is also called the trigonometric function. Now, the derivative of the inverse function of cosine is equal to the negative of 1 over the square root of 1 minus x squared. So let's take a look at the proof. Now, before we dive right in, we have to define what the limit definition of a derivative of a function is. So the derivative of any function d dx of f of x is just equal to the limit as h approaches 0 of f of x plus h minus the f of x all over h. So we're just going to plug in the inverse cosine of x into this limit. So what we're going to get is a limit as h approaches 0 of cosine or inverse cosine of x plus h minus the inverse cosine of x all over h. Now the good thing about, or the thing we have to consider when we try to prove the derivative of any inverse trigonometric function is you have to use the substitution, since if we substitute something, then we can represent it as a cosine of the something. So we would just substitute, let's say, theta 1, like the first angle, to be inverse cosine of x plus h, since the inverse cosine always represents the angle. Now, we would also represent the second angle, theta 2, to be inverse cosine of x, which means that the cosine of theta 1 is equal to x plus h, and the cosine of theta 2 would just equal to x. So if we would want to represent the h with cosines, then we can just take the x plus h and minus the x. So we have the x plus h and the x, where the x will actually cancel out. So we are just left with h, leaving us with the cosine of theta 1 minus the cosine of theta 2. Now, h is equal to the difference between two cosine functions, which means we can take in consideration that we can identify a trigonometric identity, which states that the cosine of theta 1 minus the cosine of theta 2 is minus 2 sine of theta 1 plus theta 2 over 2, and the whole thing multiplied by the sine of the difference between them. So if we have this identity, we can just equal it to h. Now, what we're going to do is we're going to solve this equation. So the equation is called negative 2 sine theta 1 plus theta 2 over 2 sine theta 1 minus theta 2 over 2 is equal to h. And we're not going to solve for h because it is already solved. We just want to solve for sine of theta 1 minus theta 2 over 2. And the reason why will come in a second. So let's divide all by negative 2 sine theta 1 plus theta 2 over 2. So divide everything by negative 2 sine theta 1 plus theta 2 over 2. And this the same thing over here. So the negative 2 sine theta 1 plus theta 2 over 2 will just cancel out over here. So we will just get some mathematical sense here. So we'll just get theta 1 minus theta 2 over 2 is equal to h over minus 2 sine theta 1 plus theta 2 over 2. Now the limit was called the limit as h approaches 0 of the inverse cosine of x plus h, now which we will call theta 1, and minus the inverse cosine of x, which is theta 2, and this whole thing by h. Now we would want to represent the theta 1 minus theta 2 into this form. Now how can we do it? We can do it we can do it if we multiply 2 and then divide the same 2 again. Then we would actually multiply by 1, leaving us with the same mathematical expression with the limit as h approaches 0 of 2 times the theta 1 minus theta 2 over 2 over h. Now the theta 1 minus theta 2 over 2 looks a bit complicated for me, so I will just substitute this with another variable. So let's take another color and let's say t. Let's say t is equal to theta 1 minus theta 2 over 2. So it is left with our limit as h approaches 0 of 2t over h. Now what is t? We have to find an expression for t. Now t is theta 1 minus theta 2 over 2, but we cannot go further with that. What we can do is we know by the fact that sine of theta 1 minus theta 2 over 2 is equal to h over minus 2 sine theta 1 plus theta 2 over 2. What we can do with this is we can plug in the t into our equation because we substitute it. So it's going to be the sine of t would be equal to h over negative 2 sine theta 1 plus theta 2 over 2. Now we want t, so we would normally take the inverse sign, but if we take the inverse sign, the expression will look very, very, very complicated. But we have some information, mathematical information we can talk about the function of sine of t. The sine of t function, for small values of t, let's take this interval, is very similar to the function y is equal to t. So it is approximately equal, which means that we can state that sine of t, so let's take the color, sine of t, that it's approximately t, and that it's also approximately h over minus 2 sine theta 1 plus theta 2 over 2. Now since we have this, we can take this approximation and let it be equal for very small values of t since h is approaching 0. When h is approaching 0, then this also approaches 0, and this will also have to approach 0 because this is approximately equal, which means for small values of t, this approximation mathematical relationship is valid, so we can use it in our limit. So our limit is going to be the limit as h approaches 0 of 2t over h, which is just equal to the limit as h approaches 0 of 2 times h over minus 2 sine theta 1 plus theta 2 over 2 all over h. Now let's see what will cancel out. The 2 and the 2 will cancel out, and the h and the h will cancel out. So it's very, very nice since the limit is now independent of h. Well, we have to take in consideration that we have set theta 1 and theta 2 to be equal to the inverse cosine of x plus h and inverse cosine of x. So let's put that in. So we have the limit as h approaches 0 of 1, so it will be negative 1, over the sine of theta 1, which is equal to the cosine, inverse cosine of x plus h, minus the inverse cosine of x, all over, plus, and then all over 2. Now, if h approaches 0, this approaches 0, so it will be equal to inverse cosine of x, and we have 2 of them. So if we have 2 of them, we say it 2 inverse cosine x over 2. So the 2's will cancel out. So what we are left with is our limit as h approaches 0 of negative 1 over sine of inverse cosine of x. Now there's another video talking about the relationship between sine and the inverse cosine inside the bracket of sine, which is just equal to -1. Now we can take the limit out because there's no h inside our mathematical expression, and this is just equal to 1 minus x squared. So I hope you really liked the video. Please like and subscribe, and we'll definitely see us in the next Daishinfinity video. See you.